Okay, we're going to take a look at this assignment you got here. It says simplify each expression to a single trig function or number. So number one here starts off with secant theta times sine theta. So I know that secant theta is 1 over cosine of theta. I'm going to multiply that times sine theta over 1. So if I multiply straight across, 1 times sine theta is sine theta. And cosine theta times 1 is cosine theta. And I know that, at least by now, that sine theta over cosine theta should equal tangent theta. That's what that is. So that's the answer for that one. Okie doke. So we're going to go to number 2 here. Cosine theta times tangent theta. Sort of a similar thing here. So we simply have cosine theta over 1. And I already said over here that sine over cosine is tangent. So here is my tangent right here. So this again will be sine over cosine. Sine over cosine. Now when I multiply straight across, what's going to happen is I get cosine theta times sine theta, if you just want to go ahead and do this, or sine theta times cosine theta, either way, over cosine theta. And what's going to happen is these cosine thetas cross out. So all you have left is sine theta, and that's your answer. Here, number 3, it says tangent squared theta minus secant squared theta. Now, if you were paying attention in class, we went over the Pythagorean identities, and one of them says that tangent squared theta plus 1 is actually equal to secant squared theta. So when I rearrange this equation, basically subtract secant squared theta from both sides and then subtract 1 from both sides, it's going to rearrange to this. It's going to say basically that tangent squared theta minus secant squared theta is in fact equal to negative 1. So you notice that this part right here is the same thing as what I have up here. So this answer is simply going to equal negative 1 because this is equal to negative 1. Alright. Number 4 is very similar. We got 1 minus cosine squared. That's another Pythagorean identity we looked at, the first one. This is very important that you understand that sine squared theta plus cosine squared theta is in fact equal to 1. So if I rearrange this guy by subtracting cosine squared theta from both sides, what I end up getting is that sine squared theta is in fact equal to 1 minus cosine squared theta. And what I see from that is that this is the same thing as what I have up here. So the answer is simply going to be equal to this. It's going to equal sine squared theta. It's the same thing. So that is the answer for this. Okay, we're going to carry on with number 7. We got 1 over sine squared a minus 1 over tan squared a. So what I'm going to say up here is that 1 over tangent squared a is actually the same thing as cotangent of squared a. So that being said, all of this right here is the same thing as cotangent squared a. Now cotangent squared a is also the same thing as cosine squared a over sine squared a. So what's going to end up happening is that this whole thing right here for number 7 is going to end up being cosine squared a over sine squared a. And basically what I'm telling you is that this part right here is the same thing as cotangent squared a. Alright, now you see here that we have a common denominator. So what I'm going to say is that's the same thing as 1 minus cosine squared a all over sine squared a. Now right here on the top we can see that this is another trig identity. This is the first Pythagorean identity. Basically means 1 minus cosine squared a is the same thing as sine squared a itself. And that's going to be over sine squared a. And then you got something divided by itself, which typically is going to give you 1. And that's what the answer is. So all that is. Let's move on to number 8. We have 1 minus sine squared theta over tangent squared theta. Now I want you to keep in mind that tangent squared theta, right here, I'm going to write it up here, tangent squared theta is the same thing as sine squared theta over cosine squared theta. That's the thing. So what's going to end up happening is I'm going to transform this tangent squared here on bottom to this. So let's see what happens. We got 1 minus sine squared theta over sine squared theta over cosine squared theta. This part right here is the same thing as tangent squared theta. Now when you divide by a fraction, what you're taught to do is multiply by the reciprocal of the fraction. So I'm going to do that. I'm going to get cosine squared theta over sine squared theta, and this is going to be ignored. When I multiply this by this, the sine squared thetas are going to cancel out. All that I have here is cosine squared theta, and of course there's 1 over here. So now what I have left is 1 minus cosine squared theta, and that by trig identity, just like the previous problem, is going to equal sine squared theta. This is your answer. Okay, we're going to go ahead and try to get this done. Number 9, let's see, we got 1 over cosine squared theta minus 1 over cotangent squared theta. Now what I'm going to go ahead and say here is that 1 over cotangent squared theta is equal to sine squared theta. Well, it's actually equal to tangent squared theta, but we're going to say it's the same thing as sine squared theta over cosine squared theta, because it's the same thing as tangent squared theta. So what I'm going to end up with here from the top here is going to get 1 over cosine squared theta minus sine squared theta over cosine squared theta. And what you're going to see from this is that we have a common denominator, both of them cosine squared theta. So what this actually is 1 minus sine squared theta all over cosine squared theta. Now what you should also notice though is that 1 minus sine squared theta it corresponds to our Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. So this actually is the same thing. This whole part right here is the same thing as cosine squared theta. It actually is. It's cosine squared theta, this part right here, over cosine squared theta. So we're going to put that over that. And when you get something divided by itself, this is actually going to equal 1. So that's the answer for that one. Number 10, this one's actually a little bit simpler. This is we're going to rewrite secant theta, because I know secant theta is actually the same thing as 1 over cosine. So right here I'm going to put, instead of secant, it's going to be 1 over cosine theta, and then minus cosine theta. And what I'm going to do is go ahead and distribute this cosine theta. So we get cosine theta over cosine theta, which is 1, and then cosine theta times cosine theta, which is minus cosine squared theta. This, as I just said before, is actually the same thing as sine squared theta, which is your answer for this one. Over here, secant squared theta minus 1. Okay, I know an identity that looks like that. We got tangent squared theta plus 1 equals secant squared theta. This is one of your Pythagorean identities. I'm going to rearrange this and go ahead and say then that secant squared theta minus 1, if I take 1 away from both sides, is the same thing as tangent squared theta. So I'm going to get rid of this part right here and say, hey, that's the same thing as tangent squared theta, because it is. So I'm going to have cosine squared theta times tangent squared theta. What that ends up happening then is that cosine squared theta gets multiplied by tangent squared theta, but tangent squared theta is the same thing as sine squared theta over cosine squared theta. And then when I multiply this by this, these right here end up canceling each other. So all I have left is sine squared theta, and that will be your answer. Here, this one isn't so bad. Let's go ahead and try this. I'm going to actually take these two binomial expressions and FOIL them, or distribute them as we should say. 1 times 1 is 1. 1 times secant is plus secant. X, negative cosine x times 1 is negative cosine x. And negative cosine times secant. Whenever you multiply cosine and secant, since they're reciprocals of each other, it's actually going to be negative. This one's going to be negative 1. Whenever you multiply cosine by secant, it should be 1, but this one's negative, so this is a negative 1. This positive 1 and this negative 1 cancel each other out. So what I have now is secant x minus cosine x. That's what I have from all that. Now don't forget to multiply this cosine. We forgot about it. So we're going to put this out here and then distribute it back in here, here and here. Cosine x times secant x is, again, is 1. Cosine times cosine is negative cosine squared x here. And this, again, is like the previous problem, well, the previous couple problems is actually equal to sine squared x again. So this answer is sine squared x. All right. Okay, and then we're down to the last two finally, so that's good. Before we start number 13, what I'm going to use is one of my Pythagorean identities here. So what I'm going to say then, the one I'm going to use is that sine squared x plus cosine squared x equals 1. If I rearrange this and subtract cosine squared from both sides, what I'm going to get from that is that sine squared x is equal to 1 minus cosine squared x. What you should notice is that this is the same thing as what I have on the bottom here. So I can actually rewrite the bottom as sine squared x because it's the same thing as 1 minus cosine squared x. So now I'll have sine x times cosine x all over sine squared x. Okay? That is sine x cosine x all over sine x times sine x. That is the meaning of sine squared. But one of these signs will cross out with this one, so we'll have cosine over sine. That's what I have. So if I have cosine x over sine x, that of course is going to equal cotangent of x. That's what that is from a quotient identity. So this is the answer for number 13. Okay, last one, number 14. Okay. Tangent squared theta on top. That's actually a trig identity. Well, it's involved in a trig identity. I'm going to go ahead and write it up here. It's tangent squared theta plus 1 equals secant squared theta. That's one of your Pythagorean identities. So we have tangent squared theta here, and I can get this tangent squared theta by itself by subtracting 1 from both sides. So if I do that and substitute it, this is what I end up getting on the top here. It's going to be secant squared theta minus 1 over secant theta plus 1 and then plus 1. This here actually though is a difference of squares. Okay, this top part here is a difference of squares. I can actually write the top part as the sum of secant theta plus 1 times secant theta minus 1. That's a difference of squares formula that you learned in Algebra 2. Okay, secant theta plus 1 on bottom. What's going to happen is that these guys are going to cancel top and bottom. And don't forget I have a plus 1 roaming here. But this negative one right here and this positive one are going to cancel out because I brought this one down and they're going to cancel out with this negative one. So all I have really is secant theta. That's what this whole thing is simply equal to. So that's the answer for the last one. Secant theta. Alright.